Okay guys, we're going to do 9.6. So go ahead and write this problem down, put me on pause, try it yourself, and then resume. Okay, go ahead and hit pause. It says find the roots of the equation x squared minus x equals 6, and they want us to do it algebraically. Roots just means find the answers. So if you look at this, this is a quadratic equation, which means that the strategy you guys have learned up to this point is to get it set equal to 0. So subtract 6 from both sides, and that would give me x squared minus x minus 6 equals 0. The leading coefficient is a 1, which means that this should be easier to factor if it's factorable, and it will be at this point because I haven't taught you what I need to teach you today for the ones that are not factorable. So x times x is x squared. Go to the last term, it's a negative. You need different signs to get to a negative. The factors of 6 are 1 times 6 and 2 times 3. Because your outers are going to be negative and your inners are going to be positive, that means you're going to have to subtract to get back to the middle term of negative 1x. That will force us to use these two. Put the larger factor with the negative. Then, once you factor it, make sure you do a quick mental check using FOIL, and then set each equal to 0. So separate them. Solve each. And that gives me one possible root of negative 2 and one possible root of 3. Then you're going to want to check them. So go ahead and put that back in. If I did negative 2, that would be negative 2 squared minus negative 2 equals 6. That's 4. Negative negative gives me 6. It checks. Then I'm going to check my 3. So this one works. So I get 3 squared minus 3 equals 6. That gives me 9 minus 6 equals, 9 minus 3 equals 6, and 6 does equal 6. So both of these roots are correct, and we have no extraneous roots. Okay, which means that if you were to graph this on a graph, it would be a parabola that would intersect the x-axis at negative 2 and positive 3. Okay, 9.6, quadratic formula and the discriminant. Quadratic formula is on your reference sheet, guys, so make sure you find that on your reference sheet because you get to use it on all the test quizzes and the EOC. Okay, and we're going to talk about the discriminant. The quadratic formula is right here. It is the ax squared plus b, that's the quadratic equation, and the quadratic formula is this. Okay, so how does the quadratic formula help us? It's a formula that will help you find the roots of a quadratic equation when you can't factor it, because not all quadratic equations are factorable. So therefore, if you can't factor it, then using the quadratic formula will get you to the answers, because sometimes the answers come out not neat and friendly. They'll come out as imaginary numbers or irrational numbers, and they're not factorable. All right, now, the discriminant is the b squared minus 4ac. That's what's under the radical in the formula. So if you think about this, the discriminant that's what they call it, is the b squared minus 4 times a times c. The discriminant will actually tell you what kind of roots you're going to end up getting. So for example, if the discriminant, I'll say d, if the discriminant comes out to 0, don't forget it's falling under a radical, so it'd be square root, therefore you're going to have one real root, one answer that's a real number. If the discriminant comes out to a positive perfect square, see if I can abbreviate all this, like say for the square root of 25, then you're going to come out to 2 real roots. If the discriminant comes out to a non-perfect, let's say positive not perfect square, like square root of 15, you're going to end up with 2 real roots, but they're going to be irrational. In other words, a decimal that goes on to infinity with no repetition. if the discriminant comes out as a negative number, no matter what, you're going to end up with two non-real roots. And we actually have talked about this when we looked at the graphs. Those were the ones where the parabola never touched the x-axis, and really we call them imaginary roots. So these are the discriminant, and that kind of tells you what you're going to get. If it's factorable, that means that you're going to come up with a perfect square, which would be one of these two scenarios. Okay, let's go ahead and apply this formula into a quadratic equation. The nice thing about the quadratic equation is that whether the quadratic equation can be factored or it can't be factored, no matter what, the quadratic formula will work for everything. So if you ever get to the point of where you don't know if it's factorable and you're trying every scenario you can think of and it's not working, just use the quadratic formula. But be careful. Make sure that when you use the quadratic formula, you get the equation into ax squared plus bx plus c equals 0 form. It might say equals y, but that's interchangeable for 0. So we're going to subtract 2x from both sides. Whoops, that doesn't cross out. This is crossing out. So we're going to end up with x squared minus 2x, putting it in the correct order. Now, let's identify. Our a is equal to 1, our b is equal to -2, and our c is equal to -8. So if they asked us about the discriminant, that would be if you ask about the discriminant, if you go back here, don't forget the discriminant is the b squared minus 4ac. So that would be b squared minus 4ac, and if we substitute that in, we get -2 squared minus 4 times a times c. That's going to give me 4. Negative times a negative is a positive. 4 times 8 is 32, and 4 plus 32 is 36. So this is a perfect square, positive perfect square. So really, this one can be factored, but they're telling us we have to use the quadratic formula. So let's go ahead and do that. The quadratic formula tells us that x is equal to -b. Copy that right down off your reference sheet. -b would be a -2 plus or minus b squared, put that in parentheses whenever you substitute, minus 4 times a times c, all over 2 times a. So let's go ahead and simplify this. Don't forget, order of operations, negative times a negative is a positive, plus or minus. We get -2 squared is 4. A negative times a negative, we just actually walked through this, and we get 32, all divided by 2 times 1 is 2. Keep bringing it down. We get 2 plus or minus square root of 4 plus 32 is 36, all over 2. That gives me 2 plus or minus. Now the square root of 36 is 6. That's a perfect square. So that guy's going to come out 2 plus or minus 6, all divided by 2. So we actually have two answers here. We have, let me write it in a different color, we have 2 plus 6 divided by 2, and we have 2 minus 6 divided by 2. The two answers are represented by the plus minus. So 2 plus 6 is 8. 8 divided by 2 is 4. 2 minus 6 is -4, and -4 divided by 2 is -2. So those would be our two roots. And then, of course, don't forget, you'd want to go back and check it to make sure that neither one of those are extraneous. All right, let's look at this problem. It's hard to see the top of it, so let me drop it down. Give me 1 second here. All right, in the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation. We're going to need a calculator on this one, so get that out and ready to go. -0.04 x squared plus 0.84x plus 2. So this is definitely a quadratic equation where x is the horizontal distance. Okay, so this is the horizontal distance. and y is the height of the ball, how high it reaches. Notice it's going up in the air, gravity takes it, it reaches its peak, the maximum, and it drops back down. So we've got a vertex happening in here, and this is a parabola. How far from the athlete will the ball land? All right, now notice we've got decimals in here. We don't even want to try to factor this. This is not going to be factorable for the most part. So we're going to use the quadratic formula. A is equal to negative 0.04, B is equal to 0.84, and C is equal to 2. So get your graph or your calculator ready, because we're going to have negative B putting it into our equation, quadratic formula, plus or minus the square root of B squared minus 4 times A times C. Extend that over. Now make sure the fraction mark goes all the way across that. All over 2 times A. Alright, so let's go ahead and get our graphing or our calculator right. Alright, so we have negative 0.84 plus or minus the square root. 0.84 squared comes out to 0.7056. Negative times a negative is going to go to a positive, and now we've got to do 4 times 0.04 times 2. That's 0.32, all divided by 2 times 0.04. That's a negative 0.08. So I'm going to bring my work way over here because I'm going to run out of space. We have negative 0.84 plus or minus. Let's take our 0.7056, add to it the 0.32. That gives us 1.0256, all divided by negative 0.08. So now I'm coming up with 2 answers here. So let's write these 2 answers. Number 1, let's do negative 0.84 plus the square root of this divided by that. So in your calculator, take the square root of the 1.0256, enter that, and then add to it negative, let's see, add to it negative 0.84, and then divide that by negative 0.08. That comes out to a negative 2.15, and it keeps going. Now understand that we're asking for x represents the distance, so it can't be a negative. So we know this one's going to be out. Try the second one. Now take your negative 0.84. Let's see if to be careful too, because calculators, when you input them, sometimes they're a pain which way you put them in. So now you're going to subtract the square root of 1.0256. And that gives you a negative 1.85, yada, yada, yada. Divide that by a negative 0.08. Comes out to a positive 23.15. They want us to, in meters, I'm just going to assume we're going to round it off, so it's going to be about 23 meters. And that's how far the ball's going to land before it hits back to the ground. Okay, there it is.